Hey guys, this is the first video for Target C. All of Target C is about making decisions about the results of sum or the product of rational and irrational numbers. So basically we're going to be adding and multiplying rational and irrational numbers, but before we can even get there, we have to look at this first video, right, 1C1, and if we look at our mastery learning objective, it says that we should be able to identify numbers as rational or irrational by determining whether it can be written as a fraction or not. So before we can even start adding or subtracting them, multiplying them, we have to be able to identify what a rational and irrational number is. So first off, rational number. Rational number is a number that can be written as a fraction. Alright, and some examples of rational numbers are, well, fractions themselves, right? Any type of fraction, like 1/3, -27/8, on and so forth. Anything that is a fraction is considered a rational number. Other rational numbers are repeating decimals. So repeating, what does repeat mean? Kind of same thing over and over and over again. So if I say the fraction of 4/3, if I were to plug that into my calculator, I would see that is 1.333333, on, which means I really write it as 1.3 repeating, and I use that little bar above the 3 to indicate that is what is repeating. Sometimes you might have an example like 7/11. If I plug that into my calculator, I have 0.636363, on and so forth. In this one, what I have repeating is the 6/3. Right? So I put a bar over those two numbers. So anything that has some type of repeating decimal is considered a rational number. Alright, the next one that is considered a rational number are normal integers. Normal integers is kind of what we're used to seeing, right? Like, for example, 5 is an integer. That could be written as a fraction because I simply put it over 1. It might have a negative, negatives are also integers. So if I have a negative 1,336, well, I can write negative 1,336 over 1. So any integer can be written over 1, which is also a rational number. The last kind of example of a rational number is a terminating decimal. So what does terminate mean? It means to stop. It ends. So if I have a fraction like 1/8, if I figure out what the decimal of 1/8 is, it's 0.125. And that's it. It stops. It terminates. Another example could be like 31/25. Right, we might have a whole number, right, 1.24. Again, my decimal stops. It ends. It terminates. Right, so those 4 examples are examples of rational numbers. Irrational numbers is the opposite, right? So it's going to be a number that cannot be written as a fraction. Right, so anything that cannot be written as a fraction. And some of these examples are, well, we have a square root, or any type of root, right? So if you have the square root of 3, or the square root of 2, or on and so forth. The only thing I would say is you do have to be super careful, because there are some exceptions, right? Exceptions would be something that is in a radical. So for example, 25, right? Square root of 25. If you were to simplify the square root of 25 in your calculator, that would tell you an answer of 5. Well, 5 is an integer. 5 is a nice number. It can be written over 1. It can be written as a fraction. So therefore, that 5 is actually rational. So sometimes the start of something might look like it is irrational, but you have to simplify. Plug it into your calculator. See if you can make it into a fraction, because sometimes you'll have a square root of a number that is a nice square, or the cube root of a number that is a nice cube, and then your answer simplifies to an integer. So just always make sure you check those square roots to make sure they can or cannot be written as a fraction. Another example for irrational number is something a decimal that is non-repeating, so the numbers kind of don't have a pattern, and non-terminating, so it goes on forever. One of the most common non-repeating, non-terminating examples is pi, right? If we evaluate pi, it's 3.1415926535 on and on and on, right? There's no pattern, it never stops, it keeps going forever. Alright, so now looking at those vocab, let's flip over to the next page, and we can look at some of these examples and see if any of these can be written as fractions or not. Alright, so looking at example 1, I had the square root of 47. If I type in my calculator, square root of 47, hopefully remember how to do the square root sign. You have to press that, yours is yellow, it's the yellow control button, and then the X squared button. And on your calculator pops up, or should pop up, a little square root sign. And then you type in 47 and enter. And why is my calculator not working? Alright guys, sorry, I got my calculator working. So, square root of 47. So press Control, then X squared, and I get that little radical symbol. Type in 47, and you see that I get this decimal, right? 6.185565. Kind of keeps going on forever. If you ever doubt that if it terminates or not, you kind of go up arrow and get the rest of the decimal. You see that it keeps going on forever. So, square root of 47 right, is equal to 6.8556546. Keeps going on and on and on and on. So this would actually be irrational. And if it does say explain in our directions, right, it says explain right there. Well, why? Because square root that doesn't simplify. Right? It's rational square root that doesn't simplify. Right? Next one. I have a fraction 11 ninths, right? That's already in fraction form. So I can already say, yep, this is going to be rational. My reason? Well, it's a fraction. Alright, the next one. If I have 96 raised to the 1/2 power. Thinking back to target B, when I change my rational exponents into radical form, this ends up being 96. Right, my denominator goes over here, my power is my exponent. This still is the square root of 96. Just like in our calculator, if we were to plug in the square root of 96, we get this really long decimal again that is non-repeating, so 9.7959858997, keeps going on forever. So example 3 is also irrational. Right, for that same reason of square root does not simplify. I'm going to zoom in a little bit, it's getting a little sloppy here. So irrational square root doesn't simplify. Alright, next one. Looking at example 4, I see the square root of 36. Well, if I type the square root of 36 into my calculator, and just to kind of show you, square root of 36 is 6. Right? If I type in square root of 36, I get a nice answer of 6. So therefore, my square root simplifies to a nice integer. So I would say yes, this is rational. Why? Because it simplifies to an integer. Right? 6 is a nice integer. Alright, our last two here. I have negative 8. Negative 8 is an integer, right? I can write that over 1 and it now changes into a fraction. So rational Why? Because it is a integer. Example number 6. Well, I see that nice whole number of a 3, but I have to evaluate the square root of 7. The square root of 7 does not simplify to a nice number. You can even check it in your calculator. You can see that it is a long decimal that keeps kind of going on forever. So square root of 7, looking at that, keeps going on and on and on and on. So 7.93725 keeps going on and on. Doesn't have a pattern, doesn't stop. So example 3 is also irrational. And why? Well, because the square root doesn't simplify. I know it gets a little tedious if you explain the same reason, but if it does indirectly state that you have to explain, please make sure you do, because otherwise you can lose those silly points on test or quizzes only because you were a little bit lazy and didn't want to write me a sentence and explain why. Alright, our last two here, I see 1.3333. Well, that was even in our example. It's repeating, right? But it repeats the same number over and over and over again. So this is an example of a rational. Right? Why? Because it is a repeating decimal. Right? The other example did not have the same number that was being repeated. It was a decimal that kept going on forever. There was no pattern. It never stopped. Kind of like number 8. We see that there is no pattern, right? There's not a repeat of the same number over and over and over again. So number 8 is an irrational. Why? Well, because it's non-repeating. And it's actually non-terminating, right? It keeps going on forever. I see those dots at the end. Non-terminating decimal. Alright, that brings us to the end of our first video. So go ahead and work on target 1C.1 activity.